Hello and welcome to the Daily Space for today, Friday, November 22nd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Now, I feel like I need to apologize. Yesterday, we encouraged everyone with clear skies to go outside and look up because there was supposed to be a meteor storm. And if you, like me, had terrible clouds, you may have even been sad about missing this amazing opportunity to see as many as 7 meteors a minute falling out of the sky. Well, despair no more. Last night's so-called Alpha Monocertides meteor storm was more like a meteor drought. European space journalist Daniel Fisher reported that an experienced meteor hunter um, only saw a slight enhancement of activity with a 5-minute peak in activity between 4:55 and 5 Universal Time. If you weren't and you aren't an experienced meteorite watcher, you likely were sad. And if you were clouded in and sad, hopefully you are sad no more. As someone who was clouded in, I was watching the radar returns, and even the radar returns were boring. This was the meteor shower that wasn't. It really was. It really, really was. So, moving along to bigger things, I guess, and continuing on our topic of rocks falling out of the sky. A new paper in Meteoritics and Planetary Science details how the aging of soils and rocks around Wolf Creek Crater in Western Australia has allowed new age estimations to be made. And when looked at in the context of all the craters on the arid parts of Australia, this allows new cratering rates to be calculated. Here's how this works. When a roughly 15-meter across and 14,000-ton rock fell out of the sky and hit what is now Western Australia, a 900-meter across crater was formed. And during that impact, sedimentary layers were flipped. This exposed rock that had been previously shielded from cosmic rays and also shielded previously exposed layers. When scientists measured how long the exposed rock on the surface had been exposed, and when they measured how long the shielded rock that was shielded for, they got two ages that matched within error. And these measurements indicate the crater was formed roughly 120,000 years ago. At this point in prehistory, humans existed in their modern form, but it isn't believed that they had reached the island continent of Australia yet. Still, the sight of that massive rock flying through the sky may have traumatized some of our most ancient ancestors. Wolf Creek Crater is the largest of many craters that dot the surface of Australia. Altogether, 7 impact events are preserved in the outback. By considering how much of the world's total surface area that land represents, it becomes possible to work out the rate at which new craters are forming. And that rate is a whole lot higher than many of us were taught. They believe that potentially crater-forming impacts may occur every 180 years or so. This actually seems consistent with what we've seen if you consider the Tunguska air explosion in 1908 or the Chelyabinsk event in 2013. Since the Earth's surface is mostly water, we also don't know what events we simply have missed in the days before satellites. So the sky is falling, just not when you're watching for meteor storms. Switching gears entirely, we are going to look at newly published observations of the massive and irregularly shaped galaxy 6240. It's been uncovered that there are 3 supermassive black holes in the core of this system. Imaged in visible light, this system is a tangle of dust, glowing gas, and star formation, and is clearly the train wreck that results from galaxies colliding and merging. It has long been assumed that this was the result of two systems coming together to form a new and larger galaxy. When the motions of this gas are measured with the high resolution Muse spectrograph on the Very Large Telescope in Chile, it actually turns out there are three massive black holes in that core. This is the first time such a trio of masses has been seen, and this changes our perspective on galaxy mergers. It had been thought that massive systems generally merge pairwise, but if most massive systems in our universe have to form one merger at a time, it becomes difficult to explain how we ended up with so many massive systems in our modern universe. If instead it is fairly common for things to come together in groups of three or maybe even more, massive systems can form much faster, and our universe makes a lot more sense. At this time, we don't know how often these many galaxy collisions take place, and more observations of more massive irregular galaxies are needed. Beyond being the target of Muse and other high-resolution spectrographs, systems like this will also potentially be observational targets of the future LISA gravitational wave detector that should maybe finally get launched in the coming years. It's thought this galaxy will merge its three black holes in a few million years, which is too long for us to wait. But it's possible that similar systems are out there and primed to complete their merger when LISA is ready to listen. And that's really all I've got for today. So, what questions have you got? While you type those in, I'd like to remind you to please use the purple circle with a purple star in the center to help me find your questions. And while you're typing those in, I just want to let you know, this is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are produced by Susie Murph, who really keeps Annie and I on track and helps make sure that all of you get all the content that you want. If you would like to see us, better support Susie, Annie, and even me, please consider donating over on CosmoQuest's Patreon page, patreon.com/CosmoQuestX. This is the best way you can help us, and it allows us to know that you're there, and it allows us to get you information. Thank you for those bits. I have a dog that heard the bits were coming. Oh, he's learned to come around. Come over here. Come on. Up. Come up. Good boy. Such a good boy. Such a good boy. Yes, you're a good boy. Hi. You can't have all of them. You can only have one at a time. I'm sorry. That's the way it works. He's a good boy. I know. Thank you so much. All your bits, all your subs, all your patronage over on patreon.com really makes everything we do possible. Now, if you can't support us financially, we fully understand. You can help us in other ways. Just get out, spread the word. Write us a review on iTunes. All these little things really matter. And thank you for everything you do. And now I'm going to find your questions and answer them because I hate begging for money, but it's part of my job. Okay, let's see what all we've got. Eddie is staring at me. He's learning to steal souls from Tink, I think. Hi, Wayne Johnson. He was the first to say hi today. Hello, Gito Bibra. Hello, Astro B. Hello, Arctifus. Hello, Larry. Hello, Broken Symmetry. Hello, Planetary Pan. Hello, Ironheart. Hello, Broken Symmetry. I think I already said that. Thank you, Astro Wise, for your sub. You've been subscribed for 14 months. That's kind of awesome. Scrolling for questions. Hello, Bad Panda. Hello, DPI 209. Astro B, why do we need Starlink now? Why? Why? I like Veronica Cure's comment that she's horrible because knowing that there was no meteor shower did make her feel better. I'm okay with that. I too am kind of cool. I was not wanting to go outside and set up my camera. So Broken Symmetry comments, I lay on the ground with my hand blocking light like a salute, and I saw one really good one and maybe two little ones. Everybody else, see more meteors. It was really just not that exciting last night from everything I was seeing. Astro Wise writes, regarding craters, what is the size constraint? So the size, thank you. What was that for? Thank you for the host over, Rishi Munster. Thank you. So, hi, I'm almost out of cookies. You don't get one for that. I so totally need to go to the pet store today. So the things that decide the size of a crater are the size of the impactor, which is more its mass than its radius. So the mass of the impactor, the velocity of the impactor, this determines its kinetic energy. So 1/2 mass times velocity squared is the energy that gets transformed into the shock blast. That total energy radiating out from the point of impact is what creates that crater. So there's really no limit on how big a crater can be other than what will disrupt our planet. But in general, since we're a fairly big world, we have to get hit by fairly big things to get destroyed. We know that something the size of Mars will work. But in general, anything over a kilometer is probably going to start to be a planet making harder to live on her. So let's hope we don't get any truly big impactors because life is good, sort of. Looking for more questions. Scrolling. This is the boring part of the show where you watch me scroll for questions. Thank you, Revs Matt, for the bits. Hi. Yes. And thank you, Trekker Kev, for the sub. This is the... Hi, that's not where you belong. There's 3 more cookies after this. Come around. Come on up. So good. Do you want this? You really want this, don't you? Hi. You're just going to stay here, aren't you? You can do that. Ugh, don't lick my fingers. My fingers need to use the trackpad. We're having a debate here. He wants cookies. I want to scroll. And he drooled on my trackpad. That makes scrolling hard. Hi. So let's see what the next question in here is. It looks like Bad Panda is asking, is CosmoQuest going to cover today's launch? I need to get with Annie. There's a chance. I don't know if it overlaps with Astronomy Cast. If it doesn't, one of us will cover it. Hi, I see you. Ruff's Matt encourages folks to try playing Universe Sandbox. And thank you for the new follows. So Astro B. London asks, what electromagnetic signatures do black holes produce for us? Well, the way that we generally find black holes isn't through their electromagnetic signature. It's through how they make everything around them move. So when the Muse spectrograph on the Very Large Telescope looked at the heart of this merging galaxy. It was able to see that the gas and dust in 3 different places were moving so fast as to indicate that in the center of all that gas and dust, there was an unresolvable black hole, because black holes are annoying and eat light rather than giving it off. So luckily, nothing else is dense enough to fit in the spaces needed for the motions that we saw other than supermassive black holes. So literally, we look for black holes whipping gas around them, and that is how we locate their positions and measure their mass. So the Event Horizon Telescope measured how light was bent around the black hole's event horizon and was looking at that gas and dust that is down near black holes. So the black holes themselves, no light. Stuff around them, bent light. It's that bent light, that accelerated material. That's what we look for when we're looking at black holes. Other questions? So while you consider typing them in, so there's an Ariane 5 launch in about 3 hours. So that is right after we're done with Astronomy Cast. So there's a chance we may be able to do that. So thank you. Bad Panda confirmed I can math. I suck at mathing in my head. I'm going to totally admit to that. So thank you for confirming I mathed. So we'll see what we can do. I'll talk to Annie. I also don't know who's simulcasting Astronomy Cast today. So things that are going on. Today, Fraser Kane and I are going to record back-to-back episodes of Astronomy Cast, where we're going to look at where do all the different atoms on the periodic table tend to come from. So this is going to be where we discuss what are the things that come from stars? What are the things that come from supernova and mergers? And it's going to take us 2 episodes to get through all that information. So come and be prepared to learn. That is going to start at the an hour and a half from now, basically, an hour and I guess 45 minutes from now. And next week, we are taking the week off. It is Thanksgiving here in the United States. I'm going to be out visiting friends, and Annie is going to be spending time catching up with family and things like that. So go forth, have an awesome week. I'm sorry we won't be here to be with you, but we are coming back fresh from the holidays to bring you more science. Are there any other questions? Thank you for commenting that it's a well-deserved week off. Thank you. So that's all I've got for today. I am now going to begin cramming nucleosynthesis back into my head in preparation for Astronomy Cast and grab some lunch along the way. So hopefully I will see some of you back here in an hour and a half. So go forth and wherever you are in the world, have a fabulous morning, evening, or afternoon. And write in the chat who I should raid. And I'll see you on the other side of either Astronomy Cast or the Thanksgiving holiday. Bye-bye.